learning zone. I'm Mr. B. After watching this lesson, you will be able to determine the displacement and the final velocity of an object that is moving with constant acceleration. Let's begin the lesson with a brief review. The term displacement, delta x, is equal to an object's final position minus its initial position. Average velocity may be calculated in two ways. First, average velocity is equal to delta x divided by delta t, or the change in position of an object divided by the change in time. Average velocity is also equal to v sub I plus v sub f divided by 2, the initial velocity of an object plus its final velocity divided by 2. Average acceleration is equal to delta v divided by delta t, or v sub f minus v sub I divided by t sub f minus t sub I. Let's use the equation for acceleration to generate an equation for final velocity. Acceleration is equal to v sub f minus v sub I divided by t sub f minus t sub I, or acceleration is equal to v sub f minus v sub I divided by delta t. Multiplying through by delta t cancels delta t in the denominator, generating the following equality. Acceleration times delta t is equal to v sub f minus v sub I, and adding v sub I to both sides of the equation cancels v sub I on the right side, generating our final equation. V sub f is equal to acceleration times delta t plus v sub I. Now arrange the equation in its final form, where v sub f is equal to v sub I plus acceleration times delta t. The expression for final velocity may now be used to determine the displacement of an object. Consider the following. Displacement is equal to 1/2 v sub I plus v sub f times delta t. Inserting the previous calculation for final velocity generates the following equation. Delta x is equal to 1/2 v sub I plus acceleration times delta t plus v sub I times delta t. Now adding the initial velocities and multiplying through by delta t generates the following. Displacement delta x is equal to 1/2 times 2v sub I times delta t plus acceleration times delta t squared, and multiplying through by 1/2 generates the following equation. Displacement delta x is equal to v sub I delta t plus 1/2 acceleration times delta t squared. Now let's apply these concepts to a real-world situation. Consider the following practice problem. A plane starting at one end of a runway undergoes a constant acceleration of 4.8 meters per second square for 15 seconds before takeoff. Question 1. What is its takeoff speed? And question 2. How long must the runway be for the plane to be able to take off? Let's begin by gathering the information given in the practice problem. We're given initial velocity, which is 0.0 meters per second. The acceleration is 4.8 meters per second square, and the change in time, the delta t, will be 15 seconds. Unknown is the final velocity, v sub f, and the displacement, delta x. Let's determine the final velocity first. Final velocity is equal to v sub I plus acceleration times delta t. Inserting information, final velocity is equal to 0.0 meters per second plus 4.8 meters per second squared times 15 seconds. The takeoff speed, the final velocity, will be 72 meters per second. Now let's determine the minimum length of the runway, the displacement delta x. Delta x is equal to v sub I delta t plus 1/2 times acceleration times delta t squared. Inserting the information, displacement delta x is equal to 0.0 meters per second times 15 seconds, which is clearly equal to 0, plus 1/2 times 4.8 meters per second squared times 15 seconds squared. Solving for displacement generates the following, where displacement is equal to 540 meters. Now let's see how these concepts are related to the New York State Physics Regents examination. The following question was taken from a recent Physics Regents examination. The graph below shows the relationship between speed and elapsed time for a car moving in a straight line. Question 1 asks us to determine the magnitude of the acceleration of the car, and question 2 asks us to calculate the total distance the car traveled during the time interval 4.0 seconds to 8.0 seconds. We're also asked to show all work, including the equation and substitution with units. Let's begin with question 1, using the acceleration equation. Acceleration is equal to v sub f minus v sub I divided by t sub f minus t sub I, which is also equal to v sub f minus v sub I divided by delta t. Inserting the information from the graph, where v sub f is equal to 10.0 meters per second and v sub I is equal to 0.0 meters per second. T sub f is equal to 8.0 seconds and t sub I is equal to 0.0 seconds. And the magnitude of the acceleration will be 1.25 meters per second squared. To answer the second question, we should use the displacement equation, where displacement delta x is equal to v sub I times delta t plus 1/2 times acceleration times delta t squared. Inserting the information generates the following, 5.0 meters per second times 4.0 seconds plus 1/2 times 1.25 meters per second squared times 4.0 seconds squared. And the displacement, or the total distance, will be 30 meters. This concludes my explanation of how to determine the displacement and final velocity of an object that is moving with constant acceleration. Hopefully this video has been helpful. Thanks for watching.